And last, the last makeup of this school year is the conservation of motion test. Number 1, the velocity of an airplane is doubled. Its kinetic energy will increase how many times? You will see those questions. Well, you don't need that, but think about kinetic energy. Ke is half mv squared. Obviously, mass doesn't change. It says the velocity doubles. So our new velocity, Ke second, is half m double velocity 2v squared is half m 4v squared. 4v, right? 4v squared. Sorry. So compare the original kinetic energy to your new kinetic energy. What's more? 4. So it's 4 times more. Okay? Next one, a block of mass that weighs 1 kilogram is moving with a speed of 5 meters per second on a smooth surface. It strikes another mass that is 4 kilograms and then they move together as one body. The energy lost during the collision is, so first, energy, obviously. If there's a loss, so it's an inelastic, right? But in order to find energy, we need to find kinetic energy, which is the velocity of the object when they collide, right? So we need to use the conservation of momentum first to find the velocity after they collide or strike each other. We already know m1 v1 plus m2 v2 equal, since they collide, move together, m1 plus m2 times v3, and v3 is the velocity they have after they strike. Okay? So mass, first object is 1 kilogram, moving at a speed at 5 meters per second. Strike another mass, 4 kilogram, not moving. Okay? And then they move together, one mass, 1 kilogram plus 4 kilogram times V3. So using algebra, V3 equal 1 times 5 is 5 plus 0. 5 divided by 5 is 1 meter per second. And then the energy lost during the collision. So so we have to find the energy before collision and energy after collision. So energy here, we're talking about kinetic energy because the things are moving, right? So kinetic energy, half mv squared. Initial kinetic energy is half mv squared plus half mv squared. First object, second object. So first object is half, the mass is 1, the velocity is 5 squared, plus the second object, half times 4 times 0 velocity. So you get 12.5. Okay? All right, that's before collision. Before. After collision, the object are together. So half m1 plus m2, they move together, times v3 squared is the kinetic energy they have after collision. It's half times 1 plus 4 is 5 times 1 square, right? Because this is a new velocity. Give you 2.5. Initial minus new kinetic energy, that means the difference is what they have lost. All right, so the difference is 10. Your answer is 10. All right, next. Okay, And 75 kilogram cart is rolling along a level road at 10 meters per second. The cart encounters a hill and coasts up the hill. Do you need to know the mass of the cart to determine the height at which the car will come to rest? No, you don't. It's because, remember when the car is moving up and down the hill, and if you determine the height, you're actually converting the kinetic energy. No, you're converting the kinetic energy, okay, all the way to potential energy. So they're equivalent. What you start with kinetic energy is what you end with potential energy. So half mv squared is equivalent to potential energy is mgh. Actually, both have m. You can cancel the m out. You don't really need to know the mass to determine how high it goes. Next, a 12 kilogram, 1200 kilogram car traveling with a speed of 30 meters per second drives horizontally off a 65 m cliff. The potential energy is, okay, so here, we don't need the speed because our potential energy is mgh. Our m is 1200, our g is 10, our h, the height is 65. So you just multiply those together, is 780,000, which is this. Okay, next. The mass 2 gram and 8 gram are moving with equal kinetic energy. Calculate the ratio of magnitude of their linear momentum. Okay. So, the best way to do this is to assume how much kinetic energy you have. Okay? I would just assume the kinetic energy you have, or both have, is 10. So, in order to find the magnitude of their linear momentum is m times v, right? So, we need to find the v in order to find momentum. How we find v? We find v from kinetic energy. Kinetic energy is half mv squared. So if your kinetic energy is 10, for the object, which is 2 gram, half times 2 times v squared, you got v squared equal 10, v equal square root of 10. For kinetic energy, which is 8, half times 8 times v squared. V squared equal 10 divided by 4, which is root 10 over 2. Okay? So your momentum of the first object, m1 times v1 equal, this is v1, v2, okay, is 2 times root 10 is 2 root 10. Vm2 v2 is 8 times its v2 root 10 over 2, which is 4 root 10. Ooh. The ratio between these two is 1 to 2 because root 10 cancel. 2 to 4 is 1 to 2. So the answer is 1 to 2. Okay? The Superman can throw 20 kilogram rocks with a velocity of 100 meters per second. A 50,000 kilogram asteroid is falling to Earth with a velocity of 5 meters per second. How many rocks must Superman throw at the asteroid in order to bring it to stop? Remember, action, reaction. In order to stop those asteroids, Superman have to throw the same amount of momentum at those to stop it, right? So, the momentum of Superman, each rock is 20 gram times 100 meter per second. Let's assume we don't know how many rocks. We say X rock should equivalent to the momentum of the asteroid. So 50,000 times 5. So you get 2,000x equal 25,000 divided by 2,000. Oh, extra 0. Divided by 2,000. X equal 125. So we need to do 125. He needs to do 125. I mean, Superman. He can do 125 in 0.003 second. So, pretty cool. Okay, next. The linear momentum of a car is the same thing. Momentum, mass, times velocity. P equal mv. 40 times 20, 800. Okay? Next, a 4 kilogram firecracker explodes into two parts. One part has a mass of 3 kilogram, moves at a velocity of 15. The other part has a 1 kilogram. What is the velocity of the second part? Remember, a firecracker is like this, right? You have two parts. If we explode, one part go up, one part should go opposite direction. And then, or you can just use calculation. Remember, when they're together, momentum should be the same, right? So, when they're together, is 0. And then when they explode, the momentum of the first part, 3 kilogram times 15 meter per second, m1 v1 plus the second part, m2, this is v2, should be conserved. Momentum when before they explode, momentum after they explode should be conserved. So 0 equal 45 plus 1 times v2 is v2. Subtract 45, subtract 45, so v2 should be negative 45 meter per second. But if you know the common sense, once you get 45, it should be opposite direction, should have a negative sign. This is a positive sign, okay? A hammer weighing 2 kilograms moving with a speed of 20 meters strikes the head of a nail, driving it 5 centimeters into the wall, neglecting the mass of the nail. So the whole thing, the nail has nothing to do with it. Calculate the impulse. Impulse is change in momentum. You're just really calculating the momentum. Here, since we're not neglecting the nail, the only momentum we have here is the hammer, right? So momentum of the hammer is mass times velocity, which is 2 times 20, 40 kilogram meter per second. I know, it's easy. Next, the brakes on a 13,540 Newton car exert a stop force of 640 Newton. the car's velocity changed from 10 meters per second to 0 meters per second, what is its initial momentum? Again, momentum is m times v. It says initial. So what's our initial velocity? 10 meters per second. So initial is 10 meters per second. Do we have mass? No, we don't. But we do have the weight, right? Weight equal mass times gravity. Gravity is 10. I always assume it's 10. So mass is gravitational force, weight divided by divided by gravity. 13,540 divided by 10 is 1354. So, oh, my bad. Let's just assume 10 or 9.81. I think the answer comes from 9.81. So use the new kilogram and times our new velocity. So it should be 13540 is this one. This answer comes from using the gravity as 9.81, but on the test, it is the test. Just use the gravity as 9.81, okay? Next, a scooter has a mass of 150 kilogram. A constant force is exerted on it for 5 seconds. During the time the force is exerted, the scooter increases speed from 6 to 18 meters per second. What is the magnitude of force exerted on the scooter? So we kind of talk about it. The only thing that we learned so far has force involved is the change in impulse, which is exactly this. Force times time equal mass delta V. Change in momentum is force times time. Okay? Both are the definition of impulse. Okay, so we're looking for the force. And we have the time, 5 seconds. We have the mass, 150. And we have the change in velocity, which is 18 minus 6. Force equal 150 times 12 divided by 5. And you'll find your answer. $360. Okay. Next, a box is initially at rest on a horizontal frictionless table. If a force of 20 Newton acts on the box for 5 seconds, what is the momentum of the box at the end of the 5-second interval? Okay. So, the momentum at the end of 5 seconds, right? Going from rest 0 second to 5 seconds is the change in impulse. So, it's the change in momentum, which is the impulse, right? Change in momentum is impulse equal to force times time. Force is 20, time is 5 seconds, 20 times 5 is 100. And also, if you just look at the unit, Newton times second. Newton, 20 Newton, times second, 5 seconds, 100 Newton second. Sometimes your answer is right in front of you. All right, next. A glass falling onto a tile floor will likely break. A glass falling onto a carpet floor will not break because the glass has more time in which to stop, which is true. Because remember the momentum. Momentum change, how much momentum at the end depend also on time. F times T, right? Equal M delta V. Impulse depend on time. When you have carpet, the carpet actually create those space. So the glass, when it fall, the carpet decrease the time when it hit the actual ground, right? So that will increase the survivalness of the glass. So it's the time that matters. The force doesn't change because how far it go down is the same thing. Since the time increase, the momentum decrease. Momentum is the same, is conserved. Since the time increase, the force decrease. So the force of the glass hitting on the floor will decrease, and then it will not likely to be broken. Anyways, the answer is true. A white pool ball of mass 1 kilogram moving at 10 meters per second collide with a 1.2 kilogram red pool ball initially at rest. After collision, the white pool ball continue in the same direction with a velocity of 3 meters per second. What is the velocity of the red ball? Red ball after collision. All right, that is. You can use the conservation of momentum, remember? Okay, so M1, M1, V1, the momentum of the first ball and the momentum of the second ball add together. M1, V1 plus M2, V2 should be equivalent to M2, V3. New velocity this time, M1, V3, and then M2, V4, because they do not stick together. They're moving separate way, so the velocity will be different, okay? Our M1, V1, M1, 1 kilogram, V1, 10 meters per second, 1 times 10, plus M2, 1.2 kilogram, initial at rest, so 1.2 times 0, equal still M1, which is 1 kilogram, times 3, and then same direction. If it's different direction, it will be negative. Since it's same direction, it will be positive 3 plus M2, which is 1.2. 1.2 times V4. That's what we're looking for. Do the math. 10 plus 0 equal 3 plus 1.2 times V4. Subtract 3 on both sides. 7 equal 1.2 times V4. Divide by 1.2 on both sides. So 7 divided by 1.2 is 5.83. Okay, it's 5.83. Okay, so this is the right answer. Somehow when I plug it in, I put 4.83. But that one is a giveaway. Last test, I give all of you this question right. No need to thank me. I actually did it on purpose. Okay. Inelastic collision result in a loss of kinetic energy. True, we already talked about it. Next, Sacramento, a 4,000 kilogram SUV is traveling 30 meters per second south, and then crash into an empty school bus, 600 kilogram traveling east. If south is positive, then east, southwest. Hold on a second. Never mind. The collision is perfectly inelastic. Find the velocity of the ride just after collision. Okay. Momentum is always conserved. It doesn't matter if it's perfect inelastic or elastic. Okay. So m1v1 plus m2v2. And also, since it's perfectly inelastic, they stick together. Okay? So that equal to m1 plus m2 times v3. So we're looking for v3. Plug in a number, 4,000 times 30 plus 6,000 times 0 equal to, add those mass up, 4,000 plus 6,000 is 10,000 times V3. Okay, and your answer is 12. Sarah goes to her apartment on the 5th floor by elevator from the ground floor. The whole journey is 11 meters. If Sarah has a mass 40 kilogram, what is the gravitational potential energy gained by her? PE, potential energy, is m times g times h. The mass is 40, gravity is 10, and then the height is 11, 4,400. Next, calculate the amount of work must be a 60 kilogram runner due to accelerate from rest to a velocity of 2 meters per second. So the work here, by looking at your answer, the work here is equivalent to the energy, right? Since that person is moving. Its kinetic energy, half mv squared. So it's half times 60 times 2 meters per second squared, which is 30 times 4, give you 120. Next, a 3 kilogram toy cart is moving at 4 meters per second. Calculate the kinetic energy if this cart is moving twice as fast. Twice as fast. 4 become 8. Kinetic energy is half mv squared is equal to half times 3 times 8 squared, which is 3 times 32, 96. Last one, a roller coaster begins at rest 120 meters above the ground. Assume no friction from the wheel or air, and that no energy is lost to heat, sound, or so on. The radius of the loop is 40 meters per second. 40 meters. The roller coaster starts moving from the very top to rest. Find the speed of the roller coaster when you reach 40 meters above the ground. So, remember, we have a roller coaster. Okay? So, if the roller coaster starts at here, which is 120 meters, and then go down and up and reach here, which is 40 meters.
Oh, I'm sorry.
And then find the speed, okay? So here at the very top, there's only potential energy. And when you reach 40, we still have height, so we still have potential energy, but also it's moving. So it also, part of the potential energy converts to kinetic energy. So what we need to do is to first find out is that the difference in the potential energy is actually the kinetic energy. Ooh. So what's our difference in potential energy? So kinetic energy is equivalent to difference in potential energy. The potential energy that's different because of the height, right? So potential energy is mg. Since it's different potential energy, is the difference in height. Equal mass is, we don't know, m Gravity is G, which is 10. And then the difference in height is 80. Okay? And that equivalent to kinetic energy. Our kinetic energy is half mv squared equal to the difference in potential energy, m times 800. Okay, coming from here. So mass and mass cancel out, and you multiply 2 on both sides to cancel out the half. Your v squared is equal to 1600. Your v is equal to 40. So it's 40 meters per second. That is the end of your test review. And good luck, guys.